Hello everyone, my name is Abhimanyu and today we are going to deal with conditional probability. So let's start. First we will see few points about set theory, then we will see terms related to probability, then we will see conditional probability, then properties of conditional probability, then question related to conditional probability. So these are our learning objectives. Now, first we will see what do you mean by probability. Okay, so number of favorable outcomes upon or by total possible outcomes. Okay, now so we will move. So first we will see basic set theory used in probability. As we know that in set theory, this rectangle will represent universal, and in probability it will only denote sample space. Okay, and these circles are denoting sets. So here it will denote some event A, event B. Okay, and what we have to see here, that what is A intersection B. So A intersection B is this common region is known as A intersection. Okay, and we have to see one formula also related to that, that is an A union B is equals to NA plus NB minus NA intersection B. Okay, so this we have to see. Now let's move. Now we will see important terms related to probability. What are the important terms related to probability? So first is random experiment. What do you mean by random experiment? So those experiment whose outcome cannot be predicted. So we can't predict the outcome. So that type of experiment is random experiment. For example, if I toss the coin, so what it will come, we can't decide. So that type of experiment is a random experiment. Okay. Now, next is, what do you mean by sample space? Sample space is that all possible outcome of an experiment is sample space. For example, if you tossed a coin, so what are the sample space? Either head or tail. If you thrown a dice, what are the sample space? The sample space would be 1, 2, 3, 4, 5, 6. Yes or no? So these are the sample space. Okay. And each point in the sample space is known as sample point. So sample space have sample points. Okay. Now, what do you mean by events? Events are those whose probability has to be calculated. Those are known as events. Okay. Now, if you want to calculate the probability, we can easily call it as event. Okay, whose probability we have to find. Now, what is mean by complementary events? Not happening of an event is complementary event, and mutually exclusive events are those events which do not have any elements common, are known as mutually exclusive events. Let us take an example. So here we can say the Venn diagram. So if it is denoting sample space, if universal is denoting sample space here, and this is denoting a set A. Okay, and set A is an event that denotes what? Event A denotes? Event A denotes getting an even prime number. So getting an even prime number is 2. So what are A complementary? A bar, A complementary A bar are those which are in the sample space but not in A event A. So it would be 1, 3, 4, 5, 6. So this is known as A complementary. Now define an event B. What is event B? So getting an composite number. So what are composite number here? Composite number is 4 and 6. So you can tell that event A and event B are mutually exclusive events because they don't have any element common. And we can also say that A and A complementary also known as mutually exclusive events because they also don't have any element common. In terms of sets, if we tell mutually exclusive events are known as disjoint sets, means their A intersection B should be 5. Okay, so we understood few important terms. Let us move. Now next is conditional events. A upon B or B upon A is the form of it. Okay, A upon B or A by B means event A has to be happened when B has already happened, and B by A means event B has to happen if event A has already happened. Okay, now let us understand what. Let us take conditional probability first define, then we will understand that. Okay, so let A and B are two events associated with the same random experiment, and the probability of the occurrence of A under the condition B, if B has already occurred, is called as conditional probability, denoted by PA upon B. Okay, now so here we can see that here it is an universal. Okay, and this is an event A and it is an event B. Okay, now what do you mean by conditional probability? That is PA upon B. Now first we have to know that event B has already occurred, and under that A have to be happened. So event B is already occurred means you have to color B. Okay, so B is colored because event B has already occurred. So event B has already occurred. Now under B, what A have to be occur under the B. So what is the reason? This is the only reason that is under B of A that has to be occurred. Okay, so this reason is what? A intersection B, as we read, and this is B. So probability of A upon B is defined as what? That now sample space is what? Just NB in B, and what is the probability of occurrence? That is N of A intersection B. And if we divide by NS2 denominator as well as numerator, so we will get P A by B is equals to P A intersection B by PB. Okay, and also we can write P B by A is equals to B A intersection B only, because A intersection B intersection A are same, by PA. So this is known as conditional probability. Got it? So let us understand this with the help of example. Before we see some few terms, then we will see the example. Okay. Now what is the few terms? That algebra of an probability. If there are two events, let us take E1 and E2 are the two events. So E1 and E2, if I will tell that we have to find what? E1 intersection E2. And if I have to tell, or I have to find E1 or E2, then I have to find E1 union E2. Okay. Now what are the properties of the conditional probability? We have to see that probability of A bar is equals to 1 minus probability of A, means probability of A complementary is equals to 1 minus probability of A. Okay. Now next thing is what? Probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. We know this. Now let us understand these all things of conditional probability with the help of an example. Taken in random experiment, tossing two coins with two hands like this. I tossed. So let us define event A is getting two head and event B is getting at least one head. It is head, it is not heads. Okay. Now getting at least two head. Okay. So at least one head or at least two head. Now if we tell that what? Event A is getting two head, event A is getting at least one head. Okay. Now, so what are the sample space if we toss two coins? So S will be head tail, tail head, tail tail, head head. Okay, these are the sample space. Now getting two head out of this is just head head, and getting at least one head, you will be head tail, tail tail. No, sorry, not tail tail. It will be tail head and head head. So these three have not this. These three have how much? At least one head. Now, if we have to find that probability of A under B, means B had already occurred. Under B, what is the probability of A? So under B, now the sample space is B. So what is the sample space? PB. So PB number of B, that is 3. And under B, what is the number of A? That is 1. So probability of A upon B is 1 by 3. Okay. So probability of getting head to head in what? Under the condition what? That probability of at least one head. So at least one head may under that, in at least one head, what is the probability of getting two head? Means under the condition of B, what is the probability of getting A? That is 1 upon 3. Okay, we understood. Let us move to the next question. Now, if P union P union, not P union, sorry, pardon. P A union B is equals to 5 by 6. P A intersection B is 1 upon 3 and P A complementary is 1 by 2. Then which of the following is or are correct? A and B are independent events. A and B are mutually exclusive events. Select the correct answers using the code given below. Now, as we know that what? That mutually exclusive events don't have any common elements means that PA intersection B should leads to 0. So it will lead, so option B is already automatically incorrect. So it is eliminated. Now only left option A. So that is option C and option B eliminated. We have the A or B. Okay. Now we know that the formula, if we have PA complementary, then we have PA equals to 1 by 2. Then we can calculate PB is equals to, with the formula of PA union B. So we can calculate PA union B, that is 5 upon 6, plus PA intersection B minus PA. So LCM will be 6. So 5 plus 2 minus 3 by 6 is equals to 4 upon 6, that is 2 upon 3. And as you know that if A and B are independent event, PA into PB, it leads to PA intersection B. So PA into PB means 2 by 3 into PA, that is 1 upon 2. It will lead to 1 by 3 and it is correct. That is 1 by 3 is only PA intersection B. So A and B are independent event. So option A is correct. That is 1 only. So that's all for today. Thank you.